Welcome, everyone. Okay, let's dive into an incredibly exciting topic today. I want you to completely change how you view your exams. Think of your Cambridge computer science exam not just as a generic test, but as an archaeological dig. Seriously, every single question contains hidden clues buried just beneath the surface of the text. Layer by layer, if you know exactly what to look for, you can reveal the perfect full-mark answer. Today, we are using hexadecimal representation as our primary dig site. Whether you're sitting syllabus 0417, 0478, 2210, or even the advanced 9618, the strategy we're going to uncover today applies across the board. We're going to dig into the exact methodology that separates average grades from top-tier success, uncovering the hidden command words and context clues that examiners are literally desperately waiting for you to find.
Here is our roadmap for today's explainer. We'll kick things off with the memorization trap, move right into our success blueprint, cover anchoring to context, dive into a fast-paced interactive workshop, and finally, wrap up with the final system. Let's get to it.
Starting with Section 1, the memorization trap.
Now, this is where we see the absolute most common point of failure for computer science students all over the world. It is incredibly frustrating, right? You study for weeks, you know the theory inside and out, you open up a past paper, especially in the data representation chapters, and it is so incredibly easy to fall back on rote memory. So why do students who know the theory still lose the marks? Well, you might know that hex is base 16. You might know it uses digits 0 to 9 and letters A to F. But treating hexadecimal as isolated, memorized facts instead of a connected computer science structure is basically guaranteed to ruin your exam scores. Examiners absolutely do not want a glossary definition. They want to see if you can solve a digital problem. Think about it. Theoretical foundations often depend on distinguishing between nearby concepts. Students frequently confuse memory and storage, or validation and verification, simply because they memorize terms in a vacuum instead of understanding how data fundamentally moves through a living, breathing system.
To really see this in action, let's look at two totally realistic students facing a past paper question for syllabus 0417. We have Alex and Sam. Now, Alex completely overloads the answer with raw computer science facts, writing out these generic labels about base 16 and binary conversion, but completely misses the actual analysis the examiner asked for. There's no depth. On the other side, we have Sam. Sam just rushes right in and completely misses the command word requirements. The question explicitly asked them to explain how, but Sam basically just wrote a bulleted list of devices where hex is used. Both of these students have knowledge, but neither of them gets the marks. They are both stuck deep in the memorization trap, giving the examiner these generic, surface-level responses that rarely, if ever, gain full credit.
So how do we fix this? Let's move to Section 2, the Success Blueprint.
We are going to introduce the absolute methodological cure to Alex and Sam's mistakes. To do this, we have to shift our entire focus away from reciting random facts to actually solving digital problems. When a really strong learner approaches a question, they systematically decode what the examiner is asking. This elevates their answers from short, simple labels to precise, terminology-rich explanations. There are 4 specific steps to do this. First, clarify purpose. What digital problem does hexadecimal actually solve in this specific scenario? Second, identify device or data. Are we talking about MAC addresses, HTML color codes, or IPv6? You have to know what you're looking at. Third, explain process. Explain exactly how the process works in a clear, logical sequence. And fourth, state consequence. What is the practical consequence for the user or the system? For example, it makes debugging a memory dump much faster for a programmer because it's shorter and far easier to read than a massive wall of binary. When these 4 questions are answered first, your terminology instantly becomes incredibly meaningful and precise.
And this leads us perfectly into the Peel framework. This is the absolute ultimate structure for your answers. Point, evidence, explanation, and link. Listen, in IGCSE style computer science, you do not reach the highest marks by writing short labels alone. The Peel framework literally forces you to connect your terminology back to the specific exam scenario. You make your point about hexadecimal. You provide evidence from the question scenario. You offer a clear explanation of the underlying process. And then, crucially, you link it directly to why it matters, perhaps explaining an advantage like reduced human error during data entry. It is a brilliant, systematic way to ensure you are answering the actual question in front of you, not the one you just wish was on the paper.
Let's test this right now. Ask yourself, which answer correctly applies the Peel framework? Is it the one that just lists isolated facts, or the one that links a specific advantage to a real-world scenario?
Take a mental moment to spot the correct application. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGC to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, if you spotted that the winning answer clearly links the hex concept back to the scenario-specific requirement, you are exactly right. That is exactly how top students secure the bag on exam day.
Let's shift gears to Section 3, Anchoring to Context.
Guys, this is a massive game changer. Examiner-style performance depends entirely on context specificity and real-world transfer. You could honestly have the best Peel paragraph in the world, but if it's about a generic computer and the question is specifically about an automated factory, you are going to lose those marks. The exact same hexadecimal patterns appear in smartphones, school network systems, industrial control, and banking. Showing these specific links is exactly what the examiners are trained to reward. Look at a generic answer. The student here suffers from memory versus storage confusion, vaguely stating that hex saves memory space. That is a classic mistake. Hex doesn't compress data, it just represents it differently on a screen for humans. Now compare that to a context-anchored answer applied directly to a robotic scenario. This student clearly explains that hexadecimal is used to display the memory dump of the robot's embedded system, allowing engineers to easily debug crash logs because hex is shorter and easier to read than a massive string of ones and zeros. Specificity wins every single time.
So how do we systematically rewrite a flawed answer into a perfect one? You follow these 4 steps. Identify the requirement, classify the data, explain the sequence, and check the context. You always need to check whether the question wants causes, effects, advantages, or design decisions. By systematically applying these 4 steps, you anchor your explanation to the exact details provided by the examiner. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 2-degree grade boundaries. Join them right now by subscribing to acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's put this into action with Section 4, our interactive workshop.
It is time to put absolutely everything we've just discussed into practice. This is going to be a fast-paced coaching session using realistic computer science data sources, moving from just understanding theory to actually applying it under simulated pressure. For Challenge 1, let's extract the core hexadecimal trend from these different contexts. Notice how in all these real-world practical applications, MAC addresses, color codes, error messages, the common mistake is assuming hex changes the underlying binary data. It doesn't. The core trend you need to grasp is that hexadecimal acts as a human-readable bridge. It condenses long, messy binary strings into shorter, manageable chunks for network administrators reading MAC addresses, web designers picking HTML colors, or technicians decoding error messages.
Moving right along to Challenge 2. I want you to identify the exact sentence in this text that loses marks due to vague wording. The paragraph here names a hexadecimal device, perhaps an embedded web server, but it completely fails to explain how it actually works. This is one of the most painfully common errors highlighted in examiner reports year after year. Students so often lose marks by naming a device or a method, or by giving an advantage with absolutely no reason attached to it. You literally cannot just say it uses hex to be better. You must explain exactly why it is better in that specific digital scenario.
Okay, Challenge 3. I am putting you on the clock. Can you write one perfect PO paragraph for hexadecimal right now? Think about everything we've covered today. Pick a context, maybe a secure communications network or a retail barcode system. Make your point, provide evidence from your chosen context, write a clear explanation of the hex process, and link it back to the specific advantage like reducing human error during manual data entry. Synthesizing these frameworks under simulated time pressure is exactly how you build the mental muscle memory needed to totally crush your Cambridge exams. If you can do this right here, right now, you can absolutely do it in the exam hall. Let's bring it all home with Section 5, the final system.
We are going to bring all the taught techniques together into a foolproof exam strategy that you can use right before exam day. Here is your ultimate, reliable memory structure for hexadecimal representation and, honestly, for pretty much any computer science topic. It uses 4 core prompts. 1. What is it? 2. How does it work? 3. Where is it used? And 4. Why is it better or worse than an alternative in that specific situation? Answering these prompts aloud prepares you for any hexadecimal question across syllabuses 0478, 2210, or 9618. If you can confidently answer these 4 prompts aloud without checking your notes, the topic is usually ready for examination use. If you stumble at all, you need to step back and rebuild the topic from the key contrast and a worked example.
To reliably achieve this, we use a 3-pass revision cycle. Pass 1, secure definitions and key contrasts. You need to know the fundamental difference between memory and storage, or a compiler and an interpreter. Pass 2, rehearse explanations. Actually draw the diagrams, write out the code-like structures, and practice those clear logical sequences. Pass 3, exam adaptability. This is where the magic happens. You change the scenario. If you learned hex using web colors, practice explaining it using robotics or industrial control instead. This layered style ensures your knowledge is incredibly adaptable to changing scenarios, not just rote memorized. Because remember, Cambridge questions will constantly try to combine theory with applied reasoning.
To summarize our entire system, here are the 3 rules absolutely guaranteeing top marks. First, command word decoding. Always know exactly what the examiner is asking for. Second, Peel framework application. Structure your thoughts perfectly every time. Third, time management matrix. Allocate your effort based on the actual marks available. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainers. When you master these 3 rules, you stop guessing and start engineering the exact answers the mark scheme demands.
Remember, generic responses rarely gain full marks. It is entirely up to you to take action on what you have learned today. The strategies are in your hands, the blueprint is crystal clear, and the path to top marks is laid out right before you. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @AceTheExams_IGCSE, to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCSE and click that bell. Don't let another exam pass you by.
I want to hear from you now. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Whether it's hexadecimal conversions, database evaluation, or just understanding exactly what the command words mean, let me know. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams, your Cambridge success starts here. I'll see you in the next explainer.